Yeah, so I'm Michael Stahnke. I'm the VP of Platform Engineering at CircleCI. You can find me on the internet all over the place with Stahnke as my username usually, and it's pretty much me everywhere if you ever see that name. Just one moment. All right, so today I want to talk about basically DevOps from a different data set. And what this came up from is over the last several years, I've worked on the state of DevOps reports, both coming out of Puppet and while I was at CircleCI, and just joining in as an author and looking at all the wonderful research and data that's been done over the last 10 years in those reports. And when I got to CircleCI, one of the things that I thought about very, very quickly was, wow, we have all of this data about what people are actually doing with software delivery. And why are we not analyzing that and kind of, overlaying that type of analysis on top of a survey analysis to get even more details about what's going on in the world of software delivery and how our DevOps practices or CI/CD practices helping us, deliver software at a higher value with a higher rate. And so I'm going to break this into three different sections, which is more around the setup, which is more about what we're talking about, why we're talking about it, the data, what we actually learned from the data, and then insights that you can glean, kind of putting some analysis on top of the data. So to begin with the setup, as I said, I've been working with the state of DevOps reports for several years, and I've authored them since 2018. And the things that we were really interested in are, kind of at first the early years were, is DevOps, what is DevOps? Do you understand it? Is it helping? Is it having better business outcomes? And then it got to, how do you model your evolutionary, journey through a digital transformation or through DevOps? And then also, what are the prescriptions? What are the things that are working for people? Because it got less from a, does this work, to we think it works, but how do we get there? And so that was kind of the next thing to unpack. And then I moved from Puppet to CircleCI a couple of years ago. And as I said, I got this giant data set of what are people doing on a platform that's doing continuous delivery, doing continuous integration. It's basically looking at all sorts of pull requests and check-ins from Bitbucket or from GitHub. And we got to just have a giant data set to look through. And so what I thought about this was, it's performance derived versus described. In a survey, you get people filling out the things they want to fill out and they answer it the way they want to. And there's also a selection bias of who chooses to answer the survey. With this, there wasn't really a selection bias because we just looked at all the data that we had. And we also get to see the differences in how people, I guess, actually work with software versus how they tell us they work. And it doesn't mean that they're lying when I say they're telling us something different. It just means they might have a different perspective on the question or how we're asking it or things like that. So this has 44,000 organizations in this data set. And so most of those DevOps surveys that have been done over the years with Puppet, Dora, and others have been about 3,000 participants. I think the max was about 4,000 participants. So you're looking at something about 10x larger than the largest single survey. And this also has 160,000 projects to analyze. So this data set is just so much more massive. And so you can see statistically significant changes over time, and also just a much larger sample to glean more information from. So if you combine all of the surveys, this data set is still about 1,000 times larger when you look at all the data points that we have. And that's because there's all these different data points we're analyzing versus just, the survey overall. So basically, these last few slides were to tell you, hey, there's a lot of data here and it's going to be really fun to dig into. And then the second thing we wanted to ask was, what's changed year over year? So I've been at Circle for about 2 years. And so this is the second year that we've done this type of analysis. And so we wanted to see, okay, the first year we took some baselines. What have we learned from year number 2? Well, we'll find out. So there's about 30 days in each of the data sets across the board, a few more orgs and a few more projects. And that's just part of the platform growing of CircleCI. And so the data set will grow. So from a classic DevOps, state of DevOps report, these were kind of the main 4 metrics, which was, deployment frequencies and recovery from failures, lead times, and change failure rate. And so what we did for ours was kind of map those into what that would be if you were using a CI/CD platform and how that would work. And so we started with mapping metrics. And so if we have deployment frequency, that's kind of how often do you initiate a pipeline? And we call that throughput. And lead time to change is pipeline duration, and we just call that duration. Change failure rate, we flipped it on its head, and we decided to call it success rate because we thought it was more positive. And then we have MTTR, or mean time to recovery, which we basically changed from time from a red pipeline to a green, or a red build to a green build. And that we call that recovery time. So you can see that we kind of mapped some analogous metrics from kind of the DevOps research that was groundbreaking and really did a lot for the industry, and tried to apply it a little more strictly to a CI/CD platform. So now let's dig into the data. We'll start with throughput, which is how often do you push code that triggers CI? Most projects are configured to run per push on a Git server. And so when I say per push, that could be many commits. It could be one commit, could be on merge request or on pull request completion, whatever. But basically, as the remote gets new content, it runs. And we can see that at the different ratings, we can see how often how much these throughputs are going on. So we have 0.03 at the 50th percentile. With the 90th percentile, you're seeing 16, and this is in this is in how many times per day. Sorry, I want to make sure I got that right. How many times per day is this being pushed through? So you can see that some projects, are being pushed not even quite once per day. But then, like, if you want to get how many are 90% of our customers doing, or the 90th percentile, you're seeing it at 16 times per day. And so what this really is telling us is that a lot of people have a lot of repos that they don't use all that often, which I don't think is surprising if you think about that from a software development standpoint. There's some that are just very rarely used, but then there's some that are used all of the time. Like 32 commits a day or 32 pipeline runs a day is probably, there's a lot of activity on those repositories. And again, that's just a little different. And so but most projects are not deploying dozens of times per day is what we can take from this. So if you saw that in the classic State of DevOps reports metrics, we had a lot on, how many times are you deploying? Well, how many times are you initiating a pipeline? How many times are you doing these things? And what we see is there's not people that are doing this dozens and dozens of times per day on average. The average is 8.22 times per day. And so what we do see is that a lot of people are not deploying dozens of times per day. And you think, well, why would these surveys tell me something different than what the actual, data on the back end is telling me? And I think the reason is that when the surveys are asking, they're asking for what's the primary application or service you work on. And I think if you break down, all of the projects that are within your organization, you may think, okay, there's a couple hundred, maybe there's more than that. But there's probably a very small amount that are actually moving very, very quickly and that are probably core to your business. And the others are tools or utilities or helpers or experiments or, very stable things that just don't move as often. And so what we see is just throughput's a very different rate here when you kind of look at it across the swath of all of the projects versus maybe just the primary application or service you work on. And the changes year over year are not that significant. Generally they're a little bit more often in 2020 versus 2019. But one thing we'll see is the average actually went up quite a bit, or the mean went up quite a bit, which is exciting because it means that the lower bounds are about the same, but the upper bounds are bigger than they've ever been, which is pulling up the average. So, some teams are just pushing code more and more often to work through this. And kind of what we can glean from that is that those leveraging CI are continuing to do so. And so they've invested something in CI and making sure that it's part of their software delivery capability. And what we can see is they're doing more with it over time. And I think 2020 was a year that allowed a lot of people to make internal investments and kind of rethink about why they're doing the things they do and what matters to them. A simple reason for that could be there are fewer developers pushing code worldwide. And so your rates could go up more. Maybe there's less collaboration or less, back and forth on reviews. We definitely saw labor cuts in parts of 2020, and we can talk about that later as we get into further analysis, but you'll see that there was definitely some impact over how much traffic was going onto the platform and how many times people were pushing code throughout specifically the early months of quarantine. Duration, this is how long does it take to get results? And so one thing about duration that's really interesting is if you have a failure, you usually get results faster than if you succeed, because when you have success, you're still running through and getting more and more information to make sure that you don't have a failure later down the line. 5% of our builds finish in less than 12 seconds, which in this sample is about 500,000 builds, just to give you a size of what this sample looks like. In 12 seconds, you probably can't do a lot. And so, you have to ask how much is that 12 seconds worth? Well, it could be that it's a step in a larger, connection of pipelines and workflows. Maybe it's just I'm putting an artifact on S3, or maybe it's I'm copying something out to somebody else, or I'm updating, documentation. It could be things like that. It could be that you have a very, very fast test suite, or you have very low test coverage. So it's hard to really say, but we have 5% of things happening in less than 12 seconds. But what we do see is about half the projects are done in under 4 minutes. And so that means they're running either very fast or they have minimal coverage or a combination of both. But we do see a lot of people really doing a lot with test engineering to bring those times down. So we'll see teams that have kind of an SLA or an SLO on, how long does it take to get results? And once it gets above a certain threshold, it's kind of pull the ripcord and let the engineers go back and do test engineering to make sure that it's shorter again, because the value of that cycle time is just so high. I've seen teams that have 10-minute limits. I've seen teams that have, a 6-minute limit. I've seen others that are very, very thrilled to have a 50-minute limit, because if you can get their results in under an hour, they're thrilled for how, complicated and thorough some of their test suites are. And you can see that, the average project is finishing in about 24.5 minutes. And again, that could give you a lot of signal depending on the complexity that you're doing, maybe through integration and systems and UAT and all of those types of things. It's hard to say exactly what's going on in each of these pipelines, but I think we can glean that people doing things in 12 seconds are probably not doing the same level of complex testing that people are doing in 25 minutes. So, but half of all builds do finish under 4 minutes. And another thing you can do is, because you can chain different pipelines together, you could have a unit testing that runs very often, and you could maybe only run system tests, well, A, once unit tests pass, or B, on a schedule when you have N commits through, or when you have, it's been 4 hours since the last time you ran or something like that. So you can see there could be some differences that way as well. 2019 compared to 2020, not a lot of significant differences here. But the one thing that I thought was really cool was that the runtime on average has gone down. So if you remember from the first metric, we saw there were more initiations of pipelines, and we're also seeing that they're running shorter. So people are basically engineering a faster throughput cycle and a faster feedback cycle in 2020. Yeah, all pipelines are running longer except for this mean, which is what I just pointed out. Success rate. How often does your pipeline complete with a green status is really the question that we're asking. And in 2020, 5% of things never ever complete green. And that's probably people that, maybe they set up CI on an experimental project they were working on, they got distracted and they never got back to it. And so it just, kind of stayed there and never had a green build. Could be there's some tests that are super difficult to work with. They never had a green build. Could be they write terrible code. I doubt that one, but could be. And then you can see that, like, above the 90th percentile, they never have a red build. And there are certain workflows that makes sense for. Maybe not makes sense, but there are certain workflows that's pretty common for. Things, again, like if you're uploading an artifact to S3, a lot of times those are shell scripts, and a lot of people don't code very defensively in shell scripts. And so in effect, it may exit 0 whether it worked or not. In other cases, it could be that people just have had very good coverage, and they do everything locally on their laptop. They make sure it's going to be green before they push it up to the CI system. And that's when they get their feedback that says, yes, everything's fine. But you can see that on average, it's about 54% of builds are in the green or pass with a green build. So some of the sample kind of in that low end where they never got to a green build is kind of dabbling with CI, but maybe not working with it fully, or maybe that project is just not as important as some of the other projects that, could be in that organization. We also saw some with no samples or no failures, as I just covered. So almost no difference between 2019 and 2020. I think this is really the only difference at the 50th percentile. We dug in a little bit deeper to kind of see if there was any other meaningful differences. And again, it's very small, but you can see that, the all green rate is a little bit lower. It's at the 85th percentile, whereas the 85th percentile last year was still 98% green. So I don't know that that's that meaningful, but we just wanted to look and see if there was anything different at all, 2019 to 2020. In terms of recovery time, this is the time that a pipeline sits in a failed state. And so, if the build goes red, what happens? And kind of the classic agile mentality is, if something's red, you stop the floor, you stop the factory, and you go fix it. This is all those people that adopted the Toyota way and other practices from manufacturing into software management. And how often does that pan out? Well, 5% of things stay red for about 2 minutes. And this could be a case of somebody submitted a build, and immediately after they submitted another build because they realized that something was broken. It could be two different developers. Somebody submitted a build and somebody else submitted a build where one person had a broken one and then one person had a green one, but that registers as a red to a green transition. But what we can see is kind of in the middle, 55 minutes is how long people take to go from red to green. So it could be, okay, I got I got the notification that my build was broken, and it took me a little bit to identify the build was broken, read the logs, figure out what happened, create a fix, do a local validation, and submit the fix back. And that took 55 minutes. That's really not that bad when you think about all the activity that has to happen there. And so that's pretty prompt. And then you see kind of at the 90th percentile, you're at 39 hours. And that's just things sitting in a red state for a long, long time. And then, of course, you get into the days. But the mean being around 14, 15 hours, the thing that I found interesting about that was that tells me that in a lot of cases, people are submitting a build, it's going red, and they're going home, and they're working on it the next morning, or going home, or turning off the lid, closing the lid on the computer, turning off the computer. Because 15 hours is about the end of the workday to the start of the next workday, of course, excluding weekends. And so it seems like a lot of people are not necessarily following the mantra of like, I can't leave with a broken build. So quick recovery time can be from multiple contributors running in parallel. As I said, if developer A submits a bad build and developer B submits a good one right after it, that's going to look like a quick recovery time measurement in our data set. And then the gap between the 50th and 75th is kind of this gap of waiting, working throughout the day versus waiting until the next day. That's really where that gap shows up between the 50th and the 75th percentile. And so you can see that things are a little, recovery time is faster, actually quite a bit faster in 2020 versus 2019. And a lot of this could be people are at home, and so they're not as distracted, or they're not out at lunch with their colleagues, and so that they got a build notification, but their food hasn't come yet, and they sit and wait for the food to complete. They're not out getting coffee with peers. Basically, they're more attentive and they're more captive. And I think that has a lot to do with how recovery times have improved more or less across the board in 2020. So the recovery times have definitely improved year over year. And so a lot of that was just me kind of, draining slides towards you and showing you a bunch of data. And that might not be the most interesting thing. And so now it's like, well, what can you gain from that data? What is the takeaway from that if you apply some different insight or analysis onto it? And that's what we'll get into for the majority of the rest of this. And I hope it's a little more engaging than just, here's data. So 2020 has been a year, complicated for all of us in our own ways. And the pandemic was a thing that we had never had anything like that before. And we had never had anything in software delivery that we could measure and say, here's the impact of a global event, and here's what we can show for it. And so we do have a little bit of that, which is interesting. So for Throughput, for those that can't see the bottom, this is March right here. And this line right here, I think is April. And then out here, I think you get like into the June, July, August timeframe. So this data set ended at the end of August. But you can see that in the pandemic, basically there's a curve for almost everything. And we'll see this throughout the rest of the data sets as well. But on Throughput, things start to go up even at the 95th percentile and even at the lower percentiles. So Throughput, basically people were putting more tests in, things were taking, or they were kicking off more, excuse me, they were kicking off more builds. And this could be developers back at their laptops instead of at conferences. It could be a lot of, people focusing on the core of their business and making sure that they had stability built for their core systems. But peak throughput from this data set until August was in April of 2020. Post then, I actually think throughput has been higher in January, but that's a whole other topic. So peak throughput was April of 2020, and I think that a lot of that was, wow, people are not traveling, they're not really going on vacation, and so you're getting almost a very close to a 100% capacity workforce working in software. And so people were just doing a lot more with their software delivery practices and using CI and CD. After April, throughput falls off a bit. And that could be from mental taxation. It could be people realizing, hey, I'm still going to take some time off. Even if I'm not going to go somewhere, I'm going to stay at home and, clean the basement, or whatever the activities are that are perhaps fulfilling to people who can't leave their house. But we do see that fall off a bit. And then duration, at the same time, when everybody is starting lockdown, we can see that durations really, they start to go up and then they fall. And so what we can kind of glean from that is people started adding more and more tests. And that could be that they're adding more tests because they want to have better coverage, or, there's a lot of economic uncertainty. I want to make sure the work I'm doing is very stable and very, business ready. And so that's something that people could be working on. but then also you start to see it fall. And I think as people got dissatisfied with the duration of their pipeline runs, they said, oh, let's just spend some engineering time on this and make it shorter, whether it's using test splitting or test parallelization, which are both, things that we can do on our platform, or, maybe just some algorithm changes, or, fixtures that are faster, or mocking that works differently, or whatever. But people started to work on getting their throughput, their duration, back down to where it was originally, or in a lot of cases, even better than where they started the year at. And so basically some engineering there to get your feedback faster. So yeah, duration started to increase in late February. And again, I think this was due to a lot of the economic uncertainty, and people tried to make sure that everything was very careful. Changes were very stable or stable made. And then increased again to the longest duration in August, because again, as people are adding more tests, basically what happens is there's kind of a camel hump over time, where you add more tests, you get more capabilities, but it takes longer. Then you do some re-engineering. Now you're back down to a low point. You kind of rest on your laurels. You don't do that engineering for a while, and then you repeat the cycle all over again. So the hypothesis is definitely more tests are written in March, driving up duration. And in April, we saw kind of the concentrated effort on optimization. And what was interesting was we saw that across the board. Those graphs moved. They don't look like they moved in like super significant ways, but when you think about that across 44,000 organizations, it is a pretty big move. The success rate overall, I think, has an interesting narrative here, in that, again, success rate goes up as everybody returns home from lockdown, kind of from being out around the globe. Success rate goes up. Maybe people are paying more attention to their builds, or they're working harder on them, or they've thrown themselves into work to distract them from everything else going on, except for this very bottom percentile where it kind of falls off. And I think a lot of this might have been, there was a lot of experimentation, or people's side projects, or maybe people, hey, I'm going to create my own project on a weekend, and then the build failed, but I'll get to it next weekend when I get back, or I don't care, or how many times people kind of look at the CI system and said, yes, it's red, but it's fine because that one test isn't meaningful because it's flaky and they haven't optimized that out, or, rework that test or whatever. So kind of in the lower end, I think we can glean that that's a lot of, I would say, different behavior than up here. Like the up here is probably more the business critical parts of the software delivery system, where it's your main application, your core business features, your business logic. And down here could be a lot of developer tooling, or it could be even things like, side projects. For me, I like to write chatbots. And so it could be, something like that, where if a test fails, or if the build's red, I'll live. It's fine. So success rates were the highest on record in April of 2020. And again, this was kind of everybody getting to crunch time, everybody working on how are we going to adapt to this mode of living, in our houses and working remotely and not being in offices. And for some companies, that was a giant transition, and for others, it was minimal. But the overall data set shows that success rates went up quite a bit. And so the hypothesis was working hard on core business stability during those March and April timeframes. And it could be that a lot of other experiments or things that people had hoped to launch throughout 2020 got derailed because, there was a whole new focus for the year at that point. We also saw recovery time kind of dropping throughout the year, which is great because it means that more people are watching those pipelines. And if they are read, their feedback is being used and consumed faster. So since April, recovery time has been improving, which means, let's see, this is golf, not bowling. You want it to be lower. And so we're seeing people do a better job of monitoring their builds, recovering faster, saying, hey, this is red, what's going on? I'm going to fix this, and being more successful with that. And the orgs with the longest recovery time is really the ones that have improved the most. If it used to be, sometimes it would take you 3 or 4 days to recover a build, you might be only at a day and a half, which is still, kind of a long tail, but quite a bit of improvement. And we saw that in a lot of cases. So the hypothesis there is that we have fewer distractions from everybody working at home. And so they're more able to pay attention to those build notifications. And of course, when we say fewer distractions, that's for some values of distraction. Everybody has their own situation that they've had to deal with or been dealing with, whether that's not a good place to work at home, or having children or other loved ones you're taking care of or living with, or, people that have, I guess, shared in your bubble for lockdown. So there could be lots of distractions, but the fewer distractions overall might be that you're not having as many walk to go get coffees, or, down in the cafeteria with your teammates, or other meetings that are even away from your computer, because even if you're attending a meeting virtually, you may still see a build notification and be able to act upon it while you're in that meeting versus, in a different room or some things like that. So one of the other things we looked at through all of this was what can you glean about branch information from a data set like this? And the reason that I kind of asked about branch information was during the summer months of 2020, we had a lot of social unrest around Black Lives Matter, and of course the killing of George Floyd. And there was a kind of a renewed push from an earlier conversation that had happened in technology around, can we get rid of this word master? It's got a lot of baggage for people, and it's not necessarily the thing that we need to talk about. It's not even the most correct word in a lot of cases for what we're using. And GitHub came out and said, hey, we're going to kind of make it so that we're not using master anymore, and we're going to use main. And I think a lot of other companies were saying, yeah, we can do something. This is something that we can do to show that we care, and because we do, and we want to move from using the words master, which is harmful language, to something as pinpoint accurate as main, which I think is actually more accurate in a lot of cases. And so we wanted to look at that. How many people had been using it? Did the use of master really decrease, I think, was really the question. And the answer is no, it didn't. Not in any significant way, but that's not yet. And as of this data set drawing, kind of closing out at the end of August, early September, GitHub had not changed the defaults on everything yet. And so it was like for some new projects, I think main was the default branch, but they weren't helping you retrofit. They didn't have all the tools up then. They do have different tools available now to make it a little easier to make sure that your default branch is not named master. So this is something that we'll continue to monitor, but I was kind of interested in the conversation here. This had started years ago with a lot of clustering software where they had master slave mentality, and they wanted to take all that away and use, things like primary, secondary, or other types of nomenclature to really just be more inclusive of everybody. And we wanted to test that from a data set from our CI side. And hopefully next year, this will be a different story, because I think it does matter. Some of the other things we can glean from branching is teams are innovating and experimenting on feature branches. And we can tell that from the different success rates that we see on the different branches, and then also how often each of them get pushed into the system. So success rate on the default branch is significantly higher than on the non-default branch. And if you think about that, if your default branch is what everybody's using and you have everybody collaborating around that branch, you want that to be in a stable, safe state, because that's the thing that everybody else is relying upon. Your own work could be in a topic branch or a feature branch where, you're trying to add a new feature, you're trying to do some work, it might not work, or it's partially implemented, and so it's broken for certain workflows or certain pathways through the code. And so that should have generally a higher failure rate. One of the things that this also tells us is that people that say they want to do trunk-based development, they're not all developing and pushing directly to trunk or main. What they are doing is still using topic branches, but those are relatively short-lived, which I think is kind of using the best of both worlds of kind of, you want to continuously integrate onto your main branch so that you don't have these giant, patch sets to go reintegrate, but you also want to have a little bit of safety and isolation so that when you're developing and innovating, you're not affecting everybody else who's trying to do work at the same time. So the success rate is 80% on the default branch at the 50th percentile, and 100% for the 75th percentile and above on the default branch. But then you look at a non-default branch, and you're looking at around 58% success. And so you just see that success rate drops quite a bit on non-default branches. And again, that's kind of that innovation in play. At least that's what we're able to glean from the data. The duration on default branches is faster than topic branches. And generally that's because people have probably engineered and streamlined that, because again, everybody relies on the main branch than they do off of the topic branches. And so topic branches, sometimes they take longer because they have new tests, or they're breaking all the time, or they're, you put in some sleep statements because you're trying to debug like a race condition or something like that. There's a lot of reasons that topic branches can be slower, but they are slower at every single percentile than the main branch, or at best they're even. Recovery time is lower on the default branch as well. And we imagine this is because more people are watching and care about the signal from the default branch than from some of the topic branches. And I guess when I say there's other topic branches, there could also be like release branches. If you have version 1 of your software, version 2, version 3, those could all be different branches in a tree, and they don't get merged between each other because they're different levels of software. But the main branch is definitely the one that is having the lowest recovery time, and we imagine that's because that's the one that most people are watching and care about. It probably has the biggest impact in overall software delivery. So from this, what development practices definitely work that we can glean from some of this branch information, and then just from the data set overall? Success rate does not correlate with company size. We don't see that large companies have much more, many more green builds than smaller companies, or different team sizes seem to have a big impact. That doesn't seem to be very meaningful in most cases. Duration overall, which is how long it takes you to get signal, is longest for a team of 1. And that makes a lot of sense. If no one else is relying upon your work, you might not optimize it because you might not care if somebody else, is waiting on the build, because they're not. So if you're having your own project, it's your own tooling or your own utilities or whatever, you might not care if it takes 15 minutes to get your test results back. Actually, if it takes you that long, you're probably doing great because you've written at least 15 minutes worth of tests. But if no one else is relying on that data, you're probably not optimizing it. And I guess that's one of the themes that you'll see throughout this. Recovery time decreases with an increased team size. So the more people you have that are looking at the content, the faster your recovery time will be. And that kind of makes sense when you think about just the impact. If you have 10 people that are all looking at the same mainline branch, and that's the thing they care about, if that goes red, there's 10 people looking at it or trying to improve it. And if you have 100, you have 100 people trying to improve it. Not a lot of projects have, 100 or 200 contributors. There are some that, definitely work at a more mono repo style that could, or it could be, it's a larger, it's the main project for the business or things like that. Or, a major open source project, I guess, would be another one where you could see things that go into the red and then get recovered very quickly. So more people, more eyes on it basically makes it so you have recovery time more quickly, which I don't think is too surprising. And the longest recovery times are also from teams of 1. And I'm just as guilty as contributing to this data set for that point, because like I said earlier, sometimes I'll write, a little chatbot thing, write some tests, it'll fail, and I won't get back to it for 4 weeks. And so it'll sit there and just be red for 4 weeks or 3.5 weeks or whatever. And I'm sure a lot of people do that. They run some tests and they think, oh, this isn't that important, and they move on to something else throughout their day. So in pretty much every indicator, performance is better, or you're getting better outcomes from the way we measure if you have more than one contributor. And kind of what that leads me to is, like, there's a collaboration element here. And that's, if somebody else is impacted by your work, you're going to be better at that work. And that's from a recovery time, from a throughput standpoint, from a duration standpoint. It's just how much are you using the integration? How continuously are you integrating your product and deploying your product or your projects? And if you have more people working on it, you're probably doing it more continuously, and you're probably working on, using those better practices faster and adopting them at a better rate. So the takeaway there is that software is collaborative. The more people you have working on it, the better outcomes you'll get in terms of just delivery and cycle time. One of the other questions I had is don't deploy on Friday a real thing? And what can we glean out of that? And so we looked into this, and we see that there's about 70% less throughput or initiations of builds on weekends. And so, okay, well, that's some good starting point. There's 11% throughput, 11% less on Fridays, and we do all UTC because it's the only thing that makes sense when you have global users. And so Friday UTC, is Thursday night in the US through Friday, I guess Friday midday in the US. And that's about 11% less. Okay, well, that's interesting. But then if you compare that to Monday is about 9% less. And that's because, UTC, again, the US is not totally online for all of that. But you do have most of Asia online and things. So, but when you look at a 9% difference versus an 11% difference between Monday and Friday, you just try and control for weekend traffic. And as you try and control for weekend traffic, you see that there's not really a significant difference between the work going on Mondays or Fridays. And so from this, we can hypothesize that people are not really slowing down on how many pushes they're doing or how many deployments they're doing on Fridays. So they're not really holding back. And I think that's really neat. People that are doing more advanced software delivery technology at this point are not as scared of, hey, I'm not going to do this work because it's a Friday and I'm afraid of it. The whole point of a great CI system is to validate change and make sure that people are confident in it. And so if you've put forth the right effort to automate the things that are going on, then and the delivery practices, then hopefully you can deploy that safely into, you know, production or into your next release or whatever is going on and however you deliver your software. But we're just not seeing that slow down on Fridays. So that was an interesting data point. And then the last thing that we kind of asked about was what language trends do we see on the platform overall? And, you know, this was just in the sample of percentages. And there are, like, once you get below about 0.5%, it's just hundreds and hundreds and hundreds of languages. But, you know, so this is kind of the builds overall. You see JavaScript and Python being a big proportion of our builds. What you can glean out of this is that people use a lot of different languages. There's not really a lot to take away that's specific. In terms of throughput, how often people are kicking off builds, Ruby takes the cake. I guess I came from a Ruby background. I felt like testing was kind of really ingrained in Ruby from the ground up. As soon as I learned it, there was always these folders that had, you know, tests, and they had test templates, and people just filled them out, which was one of the coolest things ever. And so people got very used to running tests a lot in that community. Some of these other communities have definitely adopted that over time, but that was the first one I was really exposed to. One of the things you'll see is that people are kicking off, you know, kicking off builds quite a bit, but then like the things that take a lot longer, like, you know, a Docker build sometimes take a lot longer, a C++, maybe they're kicking those off less often. Success rates overall, you're getting very high success rates in, I would say, things that don't feel like quite traditional programming to me. You know, like I said earlier in Shell, it's a lot of cases where if you don't code it very defensively, it will exit 0, even if something bad happened. You know, if you're not doing set-e or you're not doing other types of error handling. With CSS, I don't actually know how you test CSS directly. I might just be limited in my knowledge there. And then again, like with Docker files, a lot of times those succeed because they more or less interpret as shell and they can exit 0. So, you know, when you start looking at other things, you can see, I would say, more traditional programming languages pick up a little later, and you have Go and JavaScript and TypeScript. And then you kind of get all your statically typed, strongly typed languages down at the bottom here, where the success rate's a little bit harder. And that kind of makes sense. Those, you can get type errors, you can get compile errors, you can get other types of errors. So that may contribute to your success rate. Recovery time, I found this one fascinating in that there was, you know, a lot of languages that I would consider, you know, pretty modern, pretty dynamic, but then like Go just takes the cake at the top for recovery time. So apparently people writing Go care a whole lot about their pipelines and whether or not they're green or not. And so if they're red, they go and flip them pretty quickly over to green. And I thought that was really neat. That was quite different from last year, if I recall. I believe last year JavaScript was number 1 and Go was in like the 15th or 16th spot. So apparently people that have adopted Go in 2020 have really, I guess, pay attention to how their CI builds are going. And then duration. This is not that surprising to me. The things that are slower are the strongly typed C++, Swift type languages. And then the very fast things could be, you know, Shell, which again could be the entire workflow is copying a file from one, you know, like one S3 bucket to another, you know, something like that. HashiCorp language being pretty high up. And so a lot of things that I think would be, they sound like they would run fast if I think about them. And then you get to a bunch of other, you know, languages where the duration would slow down. So kind of from all that, we had a data, we had, why did we do this? What got us here? What was the impetus to look at all this data? What changed year over year? What were the impacts of 2020 and the different things we saw in terms of what the platform at large or the community at large was doing with software delivery? And now I'm going to wrap it up in just a few final thoughts. When mapped against surveying data, like CI users at 50%, using CI at a 50th percentile, show up between medium and high performers at an org level. And so to me, what this really says, which I realize it's a little bit confusing reading it, but if you're kind of average at using CI and CI/CD technology and tooling, you're probably going to show up as somewhere between high and medium on a plot of where do people show up in like the the state of DevOps metrics. And so when you think about deploy rate, frequency, and restore time, things like that. That is going, if you're just average at using CI and you're basically applying it regularly, you're going to show up somewhere between medium and high. So if you're really good at the CI stuff, you're going to show up in the high. But just basically being okay at it gets you pretty far along in your overall performance measurements, which I think is great. And so this is from one of the state of DevOps surveys where, we have kind of the metrics and the rates. And so if you're just kind of average, you're going to show up right in here, somewhere between medium and high. And I think that's pretty great. So just an investment in CI automatically moves you from and being average at it moves you from a low performance bar up into at least kind of the edge of medium to high performing. And then once you invest even more in it, and you kind of, maybe you spend a little more concentration time on test duration or test throughput and cycle time, and how often you're kicking off builds and how fast you're recovering, you can move right into the high performing group. And I don't think it's quite as tall of order as it once was seen when you looked at kind of classic software delivery and DevOps measurement metrics. And so this is basically saying that exact thing. If you're kind of average at this, you're going to be right in line between medium and high. Our most frequent users of CI have better outcomes on all 4 metrics. And so this is just, if you're just kicking off builds more, you're actually probably better at integrating your pipelines overall. And that could be because you watch the recovery time, you optimize your throughput, you optimize your tests, you optimize for feedback for other users. But that's just one of the main things is, the more you're leaning into this, the better you're going to do. And that the metrics were not designed to be like, the more you do this, you should be better at the metrics. It's just, that's kind of how they correlate. And then more collaborators means better outcomes. And I think this one was my favorite just because I'm really a human person and I like working with other people. And so the more people you're working with on your team, the better outcomes you're going to be. And that could be because you all hold each other accountable to keep, pipelines green, or keep durations low and fast feedback cycles for your software. So I guess one of the things I would say is, if you're having trouble, doing integration well, go find a partner and go work with them, and invite another one and invite another one. And that could be, for any type of software delivery. And I guess the last thing is, I'm at CircleCI and we're hiring. So if you're interested in learning more about this, working with this data set, or building the platform that helps, people create software all day, every day, you're more than welcome to apply. So thank you. I'm Michael Stahnke. You can find me at Stanma on Twitter or pretty much anywhere else. So thank you.
Great. Thank you so much, Michael. We're going to open it up for questions. Since we're a small group, I'm going to unmute folks. So you're welcome to start coming off mute and talking, or if you're shy, you could also just type in your question and I can moderate. All right. Any questions? Okay. Michael, I won't take any more of your time. Thank you so much. I will post this also on the CDF's YouTube channel under the CDF webcast playlist.
All right. Well, thank you so much. And thank you, everybody, for attending.
Yeah, thank you. Thanks for coming.
Bye.
Bye.